Good afternoon, everyone. My name is Elwama Jane Hailalapit, and I will be discussing about sampling and instrumentation. Basic concepts in samples and sampling. The sampling is a statistical process of selecting few representatives from the population, called as a sample, on the basis of which the characteristics of the total population can be ascertained. What is sample? A sample is defined as a smaller set of data that a researcher chooses or selects from a larger population by using a predefined selection method. These elements are known as sample points, sampling units, or observation. Creating a sample is an efficient method of conducting research. The sample usually represents a manageable size from this population. Researchers then collect data from these samples in the form of surveys, polls, and questionnaires, and extrapolates this data analysis to the broader community. Sample unit is the smallest unit from which sample can be selected. Census, an accounting of the complete population. Sampling error, any error that occurs in a survey because a sample is used. Sample frame, a master list of the population, either total or partial, from which the sample will be drawn. Sample frame error, the degree to which the sample frame fails to account for all of the defined units in the population. Example, if a telephone book listing does not contain unlisted numbers. Population versus sample. The population is the entire group that you want to draw conclusions about, and the sample is a specific group of individuals that you will collect data from. We have two types of sampling methods, the probability sampling and non-probability sampling. Probability sampling involves random selection, allowing you to make strong statistical inferences about the whole group. Classified into four distinct types of samples, they are simple random sampling, cluster sampling, systematic sampling, and stratified random sampling. Non-probability sampling involves non-random selection based on convenience or other criteria, allowing you to easily collect data. We can classify non-probability sampling into four distinct types of samples. They are convenience sampling, judgmental, purposive sampling, snowball sampling, and quota sampling. First method of probability sampling is the simple random sampling. This is the most straightforward way of selecting a sample. In this method, each member has an equal chance of being part of the study. The object and the sample population are chosen purely on the random basis, and each member has the same probability of being selected. The goal of simple random sampling is to create a manageable, balanced subset of individuals that is representative of a larger group that would otherwise be too challenging to sample. So how to random sample? First, you have to make a list and assign a sequential number, and then figure out your sample size, and then use a random number generator. The advantages of this simple random sampling is that this is the least bias sampling method, as every member of the target population has an equal chance of being chosen. The purpose of simple random sampling is to provide each individual with an equal chance of being chosen. However, it is expensive and time-consuming method. It is difficult to get the name of every member, especially if it is very large population. Sampling errors can occur when sample does not end up accurately representing the population as a whole. Cluster sampling is a type of sampling method where the respondent population is divided into equal clusters. Clusters are identified and included in a sample based on defining demographic parameters such as age, location, sex, etc. Example is, if the FDA wants to collect data about adverse side effects from drugs, they can divide the mainland US into distinctive clusters, like states. Research studies are then administered to respondents in these clusters. This type of generating a sample makes the data collection in-depth and provides easy to consume and act upon insights. The purpose of cluster sampling is to reduce the total number of participants in a study if the original population is too large to study as a whole. We have types of cluster sampling. Single-stage cluster sampling, as the name suggests, sampling is done just once. For example of single-stage cluster sampling, if an NGO wants to create a sample of girls across 5 neighboring towns to provide education, using single-stage sampling, the NGO randomly selects town to form a sample and extend help to the girls deprived of education in those towns. Two-stage cluster sampling. Here, instead of selecting all the elements of a cluster, only a handful of members are chosen from each group by implementing systematic or simple random sampling. Example of two-stage cluster sampling is that a business owner wants to explore the performance of his plants that are spread across various parts of the US, and the owner creates cluster of the plants. He then selects random samples from this cluster to conduct research. Multiple stage cluster sampling. Multiple stage cluster sampling takes a step or a few steps further than two-stage sampling. Example of a multiple stage cluster sampling is that an organization intends to survey to analyze the performance of smartphones across US. They can divide the entire country's population into cities and select cities with the highest population and also filter those using mobile devices. Advantages of this cluster sampling: this method is cheaper and quicker than other sampling methods. It reduces travel expenses for widely geographical population, highly external validity, and it is also practical. However, when the clusters do not mirror the population characteristics or serve as a mini representation of the population as a whole, there will be less statistical certainty and accuracy. Next is systematic sampling. It's a sampling method where the researcher chooses respondents at the equal intervals from a population. The approach to select the sample is to pick a starting point and then pick respondents at a predefined sample interval. Example, while selecting 1,000 volunteers for the Olympics from an application list of 10,000 people, each applicant is given a count of 1 to 10,000. Then starting from 1 and selecting each respondent with an interval of 10, a sample of 1,000 volunteers can be obtained. Advantages of this systematic sampling: this method is more convenient to use than other probability sampling. This method draws the samples which is evenly spread over the entire population. However, this method required complete and up-to-date frame which is not always available, require most cost and time as compared to non-probability sampling. Next is stratified random sampling. It's a method of dividing the respondent population into distinctive but predefined parameters in the research design phase. In this method, the respondents don't overlap but collectively represent the whole population. Example, if the company has 800 female employees and 200 male employees, you want to ensure that the sample reflects the gender balance of the company, so you sort the population into 2 strata based on gender. Then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. When stratifying, researchers tend to use proportionate sampling where they maintain the correct proportions to represent the population as a whole. Advantages of this method: it is efficient and manageable. It is cheap and accurate. Stratified sampling can produce more precise estimates than simple random sampling. But there's limitation in this method. It's too many differences within the population. A population can't be organized into subgroups if there are too many differences within the population. or there is not enough information about the population at hand. Non-probability sampling, first method, is the convenience sampling. Convenience sampling, in easy terms, stands for the convenience of the researcher accessing a respondent. There is no specific method of deriving the sample. Researchers have nearly no authority over selecting the sample elements, and it's purely done based on proximity and not representativeness. This non-probability sampling method is used when there are time and cost limitations in collecting feedback. Example, researchers that are conducting a mall intercept survey to understand the probability of using a fragrance from a perfume manufacturer. In this sampling method, the sample respondents are chosen purely on their proximity to the survey desk, and their willingness to participate in the research. Advantages of convenience method: it is quick and uncomplicated method of data collection. It is inexpensive and readily available sample. However, this method can be biased. Collected samples may not be representative of the population of interest, and thus, the results cannot be generalized to a greater population. Judgmental or purposive sampling is a method of developing a sample purely on the basis of discretion of the researcher, purely on the basis of the nature of study, along with his or her understanding of the target audience. In the sampling method, people who only fit the research criteria and end objectives are selected, and the remaining are kept out. Example, if the research topic is understanding what university a student prefers for master, if the question asks is, would you like to do your master's? Anything other than a response yes to this question, everyone else is excluded from the study. Advantages of this method is that it consumes minimum time for executions, allows research to approach their target market directly, and almost real-time result. However, statistically, the obtained results through these techniques are less reliable. Impurities of the sample cannot be judged. Snowballing sampling. A chain referral sampling is defined as a non-probability sampling technique in which the samples have traits that are rare to find. This is a sampling technique in which existing subjects provide referrals to recruit samples required for a research study. Example, while collecting feedback about a sensitive topic like AIDS, respondents aren't forthcoming with information. In this case, the researcher can recruit people with an understanding or knowledge of such people and collect information from them and ask them to collect information. Snowballing advantages: it enables access to hidden population, avoid risks, and save money and time. It also has limitation. It's difficult to determine sampling error, and bias is possible. Quota sampling is defined as a method in which researchers create a sample involving individuals that represent a population. Researchers choose these individuals according to specific traits and qualities. They decide and create quotas so that the market research samples can be useful in collecting data. Example, a cigarette company wants to find out what age group prefers what brand of cigarettes in a particular city. They apply survey quota on the age group of 21 to 30, 31 to 40, 41 to 50, and 50 above. From this information, the researcher gauges the smoking trend among the population of the city. Quota sampling. Advantages of this method: it saves time. It is the ideal choice for gathering primary data within a limited time. Researcher can conveniently analyze and interpret the response to the test or survey. This is because the right questions are presented to the right sample group. And the disadvantages of this method: it is risky to project the research result to the whole population because you cannot calculate the sampling error of the test from one quota. This is because quota sampling is not a probability sampling method. And lastly, the potential sources of error in research design. Total error is the variation between the true mean value in the population of the variable of interest and observed mean value obtained. Random sampling error is the variation between the true mean value for the population and the true mean value for the original sample. Non-sampling error can be attributed to sources other than sampling, and they may be random or non-random, including errors in problem definition, approaches, scales, questionnaires design, interview method, data preparation, and analysis. Non-response error arises when some of the respondents included in the sample do not respond. Response error arises when respondents give inaccurate answers or their answers are misrecorded or misanalyzed. Researcher's error arises if there's error in the measurement definition of population, the sampling frame, and data analysis. Interviewer error arises if there's error in the selection of respondent, giving questionnaires, error in recording, and cheating. Respondent error arises if there is an inability or unwillingness of the respondent to respond. Whenever a scientific study is planned, it may not always be feasible to study the entire population. In such situation, we need to apply some sampling technique to select our samples, and it's better to select probability sampling techniques. Selecting a sampling method depends on population to be studied, resources available, and importance of having a precise estimate of the sampling error.